On the grand stage of contemporary astronomy, we recently witnessed a feat that marks a watershed in cosmic exploration: the completion of the complex unfolding and alignment of the mirrors of the most sophisticated telescope ever built by humanity. This technological behemoth, designed with pinpoint precision, operates not near Earth, but in a frigid and remote orbit, a staggering 1.5 million kilometers away from our planet, in a gravitationally stable point known as the L2 Lagrange point. We are referring, of course, to NASA's James Webb Space Observatory, JWST, a marvel of space engineering that not only assumes the weighty mantle of successor to the legendary Hubble Space Telescope, but also ushers in an era of unprecedented discovery. Even in its earliest stages of commissioning, Webb has proven itself to be a time machine and a mystery solver, revealing a cosmos that is not only vaster and older, but also unexpectedly more enigmatic, more hauntingly beautiful, and complex than even the most fertile human imagination could have imagined. It is the first light of this new cosmos that brings us the next great narrative. The most eloquent proof of Webb's transformative potential came with the capture of an unprecedented, high-fidelity image of an intriguing cosmic traveler, affectionately dubbed 3I Atlas. This celestial body is no ordinary comet or asteroid from our solar system. It represents a very rare event, being only the third interstellar object, from outside the gravitational domain of our Sun, to have its passage here confirmed. Previous interstellar objects, such as Oumuamua, the first confirmed and notable for its elongated shape, and 2I/Borisov, which behaved more like a normal comet as it degassed, were observed with instruments we now consider limited. The information obtained from these past observations was fragmentary, revealing little more than basic clues about their orbital trajectories and surface compositions, leaving the true physical nature of these cosmic outsiders shrouded in dense mystery. The challenge was colossal: how to study in detail something that appears as a fleeting, spectral apparition, vanishing again into the infinite void before we could even comprehend it. The arrival of Webb, however, dramatically changed this equation, enabling detailed observation. The 3I Atlas image captured by Webb goes far beyond being a mere astronomical photograph. It transcends the status of a simple chronological milestone in the long history of space exploration. It becomes a veritable repository of precious scientific data, an unprecedented window into the secrets of the universe. This extraordinary clarity and unparalleled detail have allowed scientists to delve into the morphology of the 3I Atlas's surface, revealing a patchwork of features. Remarkably bright and highly reflective patches have been identified, interpreted as deposits of volatile ices, such as frozen water or solid carbon dioxide, which are actively sublimating, that is, transforming directly from solid to gas, under the gentle, constant heat of our Sun concurrently. Dark areas with irregular and complex shapes have been observed, suggesting scars from multiple cosmic impacts and fractures that have accumulated inexorably throughout its unimaginable, millions-year journey through deep space. This duality, displaying characteristics of both an icy comet and a rocky asteroid, is a strong indication that the 3I Atlas is a true cosmic hybrid. A body with such characteristics could only have formed in the outermost, icy regions of a distant star system, far from the central star, before being violently ejected into interstellar space by intense gravitational interactions. The observation of the coma surrounding 3I Atlas, a diffuse but distinctly visible halo of expelled gas and dust, added another crucial layer of understanding. This tenuous atmosphere of particles surrounding the object is compelling evidence of its active nature, elevating 3I Atlas from a passive rocky body to a dynamic, ever-changing cosmic traveler. While Atlas's coma is not as prominent or spectacular as those of the comets that repeatedly visit our solar system, which have already lost vast amounts of volatile material after countless close passes, its existence alone carries profound significance. It indicates that, even after traversing the immeasurable voids between stars for millennia, perhaps billions of years, 3I Atlas has managed to retain volatile compounds intact in its icy core. These compounds are now, for the first time in a long time, being actively released by the gentle radiation of our Sun. This revelation is crucial because it offers astronomers a sample of truly virgin interstellar material, that is, material that has not been altered by our system's constant solar radiation or by multiple planetary encounters, unlike all the cometary and asteroid material we know. In an almost poetic and certainly scientific sense, the atlas serves as a perfectly preserved time capsule from another star system, a cosmic treasure containing priceless, unprocessed traces of its distant place of origin. Not content with merely capturing the visual image, Webb went further, using its highly advanced spectrographs to decipher the intrinsic chemical composition of the 3I atlas. These instruments decomposed the reflected and emitted light from the body into a spectrum of revealing bands, acting as a cosmic fingerprint. The first exciting analyses already point to an intriguing combination of compounds, some familiar to our own understanding of cosmic chemistry, but many surprisingly exotic in nature. Water ice appears to be abundantly present, but it is intricately intermingled with a range of complex organic molecules, which are rare, and in some cases never before seen, in comets born within the gravitational confines of our solar system. These molecules, with their carbon chains and intricate chemical bonds, hold vital clues about how prebiotic chemistry, the molecular precursors of life, can develop in cosmic environments radically different from our own. The discovery reinforces the fascinating possibility that 3I atlas, and other travelers like it, act as universal seeds of prebiotic chemistry, key ingredients capable of transporting the molecular building blocks of life to potentially habitable worlds throughout the galaxy. If the atlas carries these elements, it strongly supports the hypothesis that interstellar objects are indeed active messengers of cosmic chemistry, spreading the essential building blocks for life throughout the vast and interconnected Milky Way. The dimensions of the 3I atlas, magnificently revealed by the unparalleled clarity of Webb's images, add another layer of profound fascination to its nature. In striking contrast to the first interstellar object, Oumuamua, a relatively thin and elongated fragment only a few hundred meters across, or to 2I/Borisov, which was a relatively small body perhaps a kilometer across, the 3I atlas boasts several kilometers in length at its longest dimension. This substantially larger size brings it closer to the size of a well-established comet nucleus than to a mere cosmic fragment. Its sheer scale suggests that it survived, impressively intact and robust, a violent ejection from its star system of origin, a process that likely involved dramatically powerful gravitational interactions, perhaps with newly formed giant planets or neighboring stars passing dangerously close to its stellar cradle. The mere observation of an object of such magnitude traversing the immeasurable distances between stars is a telling testament to how dynamic, and sometimes brutal, the processes of planetary and star formation can be. If an object of this size can escape and endure this journey, it's reasonable to infer that many others like it do so, transforming interstellar space not into an inert void, but into a veritable, silent highway of errant debris, drifting from one star system to another, invisible until the right moment. The 3I atlas's orbital trajectory, plotted with surgical precision from data provided by Webb and other ground-based observatories, unquestionably solidifies its interstellar origin. Precise measurements demonstrate that it is following a hyperbolic orbit, a path that curves around the Sun at a speed and trajectory that prevents it from being held by solar gravity, meaning it will cross our solar system only once before bidding farewell forever to the void of space. Unlike comets periodically trapped by our Sun's gravity, Atlas will not return. It is a traveler merely passing through, a cosmic instant frozen by Webb's technology in previously unimaginable detail. This knowledge adds a certain melancholy to the discovery, underscoring its ephemeral nature, a visitor we will never see again. Yet it is precisely this fleeting nature that underscores, with unquestionable urgency and importance, the Webb telescope's revolutionary role in capturing such fleeting yet scientifically crucial moments. Without Webb's unique capabilities, 3I Atlas would have gone largely unnoticed, reduced to a faint and obscure entry in an astronomical catalogue. Now, it has become a fundamental case study, essential to our understanding of the birth, evolution, and remarkable resilience of interstellar travelers. Astronomers are currently engaged in a process of meticulous comparison between 3I Atlas and the two previously confirmed interstellar objects, Oumuamua and 2I/Borisov. While Oumuamua's remarkably elongated shape has sparked a flurry of theories, some speculating on a possible artificial origin, Atlas, in contrast, appears more conventional in its basic structure, yet reveals itself to be profoundly exotic in its details of chemical composition and surface characteristics. Similarly, while Borisov behaved largely like a typical comet in terms of outgassing, Atlas exhibits an intriguing hybrid personality, defying simple categorization. These distinctions, rather than being mere variations, are invaluable information, as they demonstrate the vast and surprising diversity of objects that are violently ejected from other star systems, directly reflecting the infinite variety of planetary architectures that fill our galaxy. The Webb image, in this sense, is not just a record, but tangible proof. Each new arrival of an interstellar object represents a unique and irreplaceable opportunity to glimpse the distant history of another world, opening a portal to the unknown. The impacts of these revelations, beyond the field of pure astronomy, echo in several other scientific spheres. Existing theories of planetary formation must now be revised and expanded, incorporating the robust evidence that objects as large as kilometers across can not only be ejected from their parent systems, but also travel colossal interstellar distances while remaining largely intact. For astrobiology, the science that seeks to understand life in the universe, these new data are crucial, as they concretely demonstrate how the essential chemical precursors of life can be disseminated and distributed across vast regions of interstellar space. Cosmochemistry, which studies the formation and distribution of elements and compounds that shape worlds, gains an invaluable laboratory sample, perfectly preserved far beyond our solar cradle. And even philosophy itself finds profound resonance in this moment. The contemplation of the fact that matter originating from distant, previously unknown stars is literally passing through us, tangibly and observably in real time, drastically expands our conception of belonging and interconnectedness in the universe. It is a vivid reminder that we are not isolated, but rather embedded in a vast web of cosmic interactions. The visual and cultural impact of Webb's 3I Atlas image cannot be underestimated. For the general public, this photograph transcends the scientific and the didactic, presenting a visceral and moving invitation to the sublime. Unlike abstract theoretical models or blurred images from bygone eras, this is a real, extraordinarily sharp photograph of an interstellar traveler, glowing softly against the backdrop of an intricate star field. It manages to render the immense and often impersonal vastness of the galaxy suddenly intimate, almost personal. The image provokes profound questions. Somewhere, did a planetary system give birth to this object? At some point in the unimaginably remote past, did cosmic forces launch it on a trajectory that, by extraordinary statistical chance, crossed our little, solar neighborhood? Looking at this image is like leafing through a history book etched in rock and ice, a narrative unfolding over millions of years and incalculable distances. Furthermore, this monumental feat by Webb vigorously fuels the conversation about how humanity might, in the ever-nearer future, interact more directly with these objects. Today, our capabilities are limited to remote observation, content with the light they reflect. But as images become more detailed and the catalog of interstellar visitors expands, the audacious idea of sending robotic probes to intercept and study them up close becomes increasingly tangible, an ambition scientifically motivated by the promise of touching material from another star system. For the scientists, engineers, and the vast international team who have dedicated decades of their lives to the James Webb Project, this moment of capturing the 3I Atlas is a resounding and invaluable validation of a monumental endeavor. The telescope was meticulously designed with two primary objectives: on the one hand, to peer into the distant past of the universe, detecting the first light from primitive galaxies, and, on the other, to examine objects within our own galactic neighborhood with unprecedented detail, especially in infrared light. Atlas's capture, in essence, masterfully unites these two missions, transforming a local observation, an object passing through our system, into one with cosmic and universal implications. Each pixel of this image is not just a piece of data, but the culmination of unimaginable precision engineering, impeccable space deployment, and patient mirror alignment. Seeing the decades-long vision come to fruition in a discovery of such depth is a collective triumph for the entire global scientific community and a testament to human ingenuity. This success also underscores the vital interconnectedness between scientific disciplines. Engineers, physicists, chemists, and computer scientists have contributed synergistically to the creation of a tool capable of seeing the unknown. The wonder of the Three-Eye Atlas, more than its obvious singularity as an object, lies profoundly in what it represents conceptually. It is irrefutable proof that interstellar space, far from being an inert and silent void, is vibrant and alive, teeming with myriad travelers and pilgrims, each carrying with them an intimate and priceless story from a different star. The image captured by Webb crystallizes this galactic reality in a way that mere words, no matter how elaborate, could never fully express. For the first time in human history, we can look at a truly interstellar object and see it with unquestionable clarity, with intricate details that make it palpable, present, and incredibly real, rather than an abstract concept or distant theory. This fundamental transition from the unknown to the tangible, from the theoretical to the observable, is profoundly transformative for our understanding of the cosmos. It also signals a crucial evolution in the philosophy of astronomy, which now values alertness, rapid response, and the ability to study transient events as much as the observation of stable, long-term patterns. Beyond its contribution to individual astrophysics, the Three-Eye Atlas offers us profound insights into galactic ecology. Galaxies are not static collections of isolated star systems, but rather vast and dynamic cosmic ecosystems where stars are born and die, planets form, and cosmic debris endlessly migrates. The ejection of interstellar objects, such as the Atlas, is a natural and fundamental part of this process. It reveals that our own solar system is embedded in an intricate galactic network of material exchange, with the Milky Way acting as a vast, interconnected web, not a collection of isolated islands. The scars and deposits of the Atlas also make us geological ambassadors of alien planetary architectures, as it holds the memory of its home system, which was likely very different from our own. Its existence forces us to rethink the diversity and violence intrinsic to the formation processes of other worlds, where dramatic gravitational interactions can hurl thousands of objects into the cold interstellar abyss. Webb's precision allows us to begin to decipher these galactic scars, interpreting the Atlas as a time capsule that transports the itinerary of cosmic events spanning millions or billions of years. Finally, the Atlas, observed by Webb, revives and expands crucial theories, such as panspermia, suggesting that the molecular ingredients of life can be transported between star systems. By detecting complex organic molecules, Webb has provided robust evidence that this transfer of biotic material is not merely theoretical but is actually occurring. The object serves as a centerpiece in one of the greatest debates in science: how and where life begins in the universe. Furthermore, Webb's ability to study both exoplanet atmospheres and solid interstellar remnants provides a comprehensive three-dimensional perspective on alien systems, connecting the climate and surface composition of active worlds with the building blocks that formed them. The very arrival of the Three-Eye Atlas was an act of rare gravitational choreography, a cosmic alignment that allowed humanity's most advanced telescope to witness and document a fleeting event in unprecedented detail. The James Webb Space Telescope, in revealing the first real image of the Three-Eye Atlas, did not merely reveal a photograph. It opened a conceptual and factual door to the history of another star system, transported across the interstellar abyss in the form of a wandering body. The image will be studied for decades, cited in future textbooks, and remembered as the defining moment when interstellar objects transcended the realm of ephemeral mysteries and became established as observable and fully investigable realities, making the universe more immediate, dynamic, and intrinsically connected than we had ever imagined.